So I know we spent a couple of days working on word problems in our last unit. Today we're going to look at some more word problems, and this time we're looking at them with systems of equations. Now, this is where I think systems of equations actually make the most sense, is when you're dealing with situations where you actually can relate them to things. And so the system of equations applications or word problems, it says many real world problems can be modeled, meaning you can take situations in real life and then turn them into these types of problems to actually figure them out a little bit quicker using a system of equations. The process below, use the process below to solve these problems. Now, as it is with most word problems, there isn't just one way to set it up and solve it. And so you're going to have to kind of learn how to work through these problems and recognize the different types of problems that we see. It's not going to be as set up as the type 1, type 2, type 3, type 4 we saw from the previous unit. This will be a little bit more open-ended. But every single one of these problems will have two variables and two equations. And so step 1 says to define your two variables. Most of the time, almost every time, and actually we may as well just use x and y every single time. That's what we're used to using. So your two variables will be x and y. Those are the things that you're solving for. Write a system of equations using the given information. System of equations means write two equations. Solve the system. And then that would be using either substitution or elimination to solve the system. And then answer the question, answer it, give it exactly what the problem is asking for. So I'm just going to write a couple small things underneath step 1 and step 2. So underneath step 1, I'm going to write x and y. So x and y, those will be our two variables that we'll use. You're welcome to use different variables if you would like, but we're just really used to using those, so we'll just keep using those unless you want to change them on your own, which is fine. Write a system of equations. So write two equations. Write two equations. And then step 3, solve the system. That would be either substitution or elimination. And then give an answer for it. So we're going to jump in here, take a look at number 1. Almost all of these, actually all 6 of these first problems are very similar to one another. We might not do all 6 of them because once we get through a couple of them, I'll get you your assignment and then we'll actually work on that one from your assignment that looks like one of these here. So problem number 1, it says the sum of two numbers is 30 and their difference is 12. Find the two numbers. So the first thing we need to do is define our variables. And so what we're going to say is, we'll just say x will be the first number. And then we'll say y will be the second number. X is the first number, y is the second number. And what we need to do is write two equations based on what we know about these two numbers. And we know that the sum of the two numbers is 30. What does sum mean? Yeah, the addition, the answer to an addition problem. So if we add these two numbers together, the sum of the two numbers, so the sum of x and y, so that'd be x plus y equals 30, because it says the sum of the two numbers added together equal 30. And it says that their difference is 12. What does difference mean? Answer to a subtraction problem, yeah. So sum, addition, difference, subtraction. So if we subtract the two numbers, x minus y, it tells us that that is equal to 12. So the sum of two numbers is 30, x plus y equals 30. The difference of the two numbers, x minus y, is 12, so x minus y equals 12. Find the two numbers. So taking a look here, this is our system of equations. Which method would you prefer to use here? Substitution or elimination? Yeah, I would say elimination is a good one here because this sets up really well for elimination. Every value with x and y here is equal to 1. So I'm just going to put 1 with each of those. So the coefficient, the number in front of x and y. And this is already set up for elimination because the x's are lined up, the y's are lined up, the regular numbers are lined up, and the equal signs are lined up. And we actually have an option here. We could add or subtract depending on which you would prefer. We could add them together because we have opposite values with y, or we could subtract them because we have the exact same value with x. Now, I think we were mostly trying to work with addition on these because we, most of the time adding things together tends to be a little bit simpler. So because we have that option, let's take that option. We'll add the two equations together. So when we add these together, we're going to have 1x plus 1x, which is 2x. And then positive 1y plus negative 1y means that the y variables cancel out. And then 30 plus 12 is 42. So we just add everything together. And we end up with 2x equals 42. And then if we solve for x, that means we're going to divide both sides by 2. And x equals 21. So we have our value of x. Now we need to solve for y. So we can plug this back into either one of our two first equations. Let's just plug it back into the first one. We'll just solve this over here. So x plus y equals 30. So 21 is x. So 21 plus y equals 30. And if we subtract 21 from both sides, that'll get us y by itself. 30 minus 21 means that y equals 9. So the two numbers that we have, the two numbers that add to 30, x plus y, 21 plus 9, that equals 30. And the two numbers that we have, their difference, 21 minus 9 equals 12, and that's also true. So our two numbers are 21 and 9. All right. So at its base, this is how we're going to do it. We have to define our two variables, x and y. We need to write our two equations, and then we have to use one of our two methods of solving systems using either elimination or substitution. Problem number 2 is similar enough to number 1 that we're going to skip number 2. And then we will take a look at number 3 next. Let's look at that one. So number 3. It says the difference between two numbers is 9. The first number plus twice the other number is 27. Find the two numbers. So again, we're being told to find the two numbers. So it's going to start off defining our variables just like we did on problem number 1. We're trying to figure out a first number and a second number. So x will be our first number. And then y is going to be our second number, just like we had before. We've defined our variables. Now the first sentence gives us our first equation. The difference between two numbers is 9. So that'd be x minus y equals 9 because difference means subtraction. So x minus y equals 9. Now the second equation, it's a little bit more challenging this time. It says the first number plus twice the other number is 27. So the first number, x, plus twice the other number means 2 times the other number. The other number is y, so that'd be 2 times y. Is means equals, and then 27. So it looks a lot more challenging, but if we break it down word by word, first number x plus twice the other number, 2 times the other number, which is y, so 2 times y is equals 27. So on this one here, would you prefer substitution or elimination? What would you prefer? What's that? Okay, so elimination again, I agree. I shouldn't say I agree. I would say that works perfectly fine. We could use substitution if we wanted to. We'd have to do a little bit of work first. So let's go ahead and work through this. I'm going to put a 1 in front of the x's. I'm going to put a 1 in front of the minus y. And then on this one, we have to subtract because we're going to be eliminating the x's. So 1x minus 1x, the x's cancel out. Negative 1y minus 2y is negative 3y. And then 9 minus 27 is negative 18. So 3 is going to be negative 3y equals negative 18. And then to solve for y, we'll divide both sides by negative 3. And negative 18 divided by negative 3 means that y equals 6. So y equals 6. And then to solve for x, we have to plug back in to one of our first two equations. I would recommend just plugging into the first one because those are just x and y. So we'd have x minus y. We have y, so it'd be x minus 6 equals 9. Plugging back into the first equation. And then we will add 6 to both sides, plus 6, and that'll get us x by itself, which is exactly what we want, which is 15. So x equals 15. And you can double check your answers just to make sure that these actually work. Our first number is 15, our second number is 6. If you find the difference of those two numbers, 15 minus 6, x minus y, that equals 9. So that's good there. And then if you take 1x, so 15, plus 2 times 6 plus 12, 15 plus 12 equals 27. So it checks out. Both of those numbers work. And so our answers here are 15 and 6. So notice right now, we're not writing our answers like a point on a graph because we're not just dealing with linear equations in terms of graphing. We're dealing with a more, I guess, a more real world scenario. The next page has even more, like, I would say, useful type questions. 4 is very similar to 3. And we're going to skip 5 as well. We'll do 6. We'll just do 3 from this first page. So we'll do 1, 3, and 6. Now, number 6 says the sum of two numbers is 25. So again, it starts off very similar to the first two problems we've seen. And then this says one number is twice the second number plus 7. What are the two numbers? So again, we're trying to figure out the value of two numbers. So we can start by saying x is the first number, and then y equals the second number. So at the very least, hopefully you can define your variables when we're dealing with these. You're always trying to figure out two things, two amounts, two values, whatever it is. And then it says the sum of those two numbers is 25. So if we add those two together, because sum means add those two together, you get 25. So x plus y equals 25. Now the second sentence is a bit different. It says one number is, so one number meaning the first number, x. One number is twice the second number plus 7. So when it says one number is, that means x is, which means is means equals. So we're going to say x equals. This time it's a little different. We don't have x and y on the same side of this next equation. So the first number, x is, x equals twice the second number. So that would be the second number, y times 2, so 2y plus 7. What are the two numbers? All right, so those are our two equations. X plus y equals 25, and then x equals 2y plus 7. So one of them tells us what they are equal to when you add them together. The other one compares the values of both of them with one another. What method do you think would be most useful on this one? Or I guess, which method do you prefer? Because it doesn't really matter. We could use elimination. I, though, would recommend substitution on this one. And just as a way to review substitution, we'll do that. The reason why I say substitution is because On this second equation, we have a variable all by itself already. When you have a variable all by itself to begin with, it's ready to go for substitution. So this says x equals 2y plus 7. So what we're going to do is take what x is equal to, and then we're going to plug that in into the other equation. So it says x equals 2y plus 7. So if this one down here, this x down here equals 2y plus 7, the x up here also equals 2y plus 7. So we're going to rewrite the first equation, but instead of x, we're replacing it with what x equals, which is 2y plus 7. So we're going to say 2y plus 7 plus y, because that's the other part of that equation, equals 25. So we have x here, 2y plus 7, and then y here, which is just y, equals 25. So this is the sum of the two numbers, equals 25. I'm going to put a 1 with this other y right here because on the left-hand side, we have 3 terms. 2 of them have a y with it, which means we can put those together. So 2y plus 1y is 3y. So that's 3y plus 7 equals 25. And then we can solve for y. So if we subtract 7 from both sides, minus 7, that gives us 3y equals 25 minus 7, which is 18. 3y equals 18. And we'll divide both sides by 3 to get y by itself. And 18 divided by 3 means that y equals 6. That's what we got on number 3 as well for y. Interesting. All right, so y equals 6. Now we have to solve for x. Solving for x on this one means we can just plug in our value of y back into the second equation because x was already by itself in that equation. So if we plug that back in, we're going to get, I'll just do that math over here. So we'll say x equals 2 times y, y is 6, so 2 times 6 plus 7. And 2 times 6 is 12, and 12 plus 7 is 19, so x equals 19. So the two numbers that we get on this one, 19 and 6. So those are our two values for x and y on problem number 6. All right. So what we're going to do is we're going to pause for a second. I'm going to hand out your assignment. And what I would like for step 1, how did you write out the x and y like we did on the first 3 problems? Same way? The x is the first number, y is the second number? Okay, good. So x, first number. And then y is the second number. Regardless of the problem, we should always be able to define our variables. Anytime we're working through a problem, even if it's a problem like this, or even on the next problem, I would hope that you'd be able to define your two variables no matter what. Next is going to be L. What do you have for the first equation? X plus 3y equals 24. Good. So one number added, so x plus, right? One number is x, that's the first number. Added means plus, so x plus 3 times the other number, or 3 times another number, 3 times the second number, which is y, so 3y is equals 24. So x plus 3y equals 24. Good. The second equation. Let's see, Sophia, do you have anything? Oh, yeah, just left. Let's see. Wait, did I hear somebody? Yeah. 5 times the first number, so 5x, yep, plus added to, yes, 3 times the other number, 3y, yep, equals 36. Nice. So those are the two equations that we need. First number is x, second number is y, first equation, second equation. I'm going to leave it at that. I want you to be able to solve that, and you can do that later. But I wanted to give some assistance in terms of getting you started with some of these problems on your assignment today. So we'll leave that one there, and then we're going to head back to our notes. So please make sure that you have this in on your assignment. And I would recommend elimination for this one. And I'll have you get started on that later. So let's take a look at page 2. By the way, we're going to spend 2 days on our word problems because there are actually 2 more pages of notes, but we're not going to go over every problem as you've seen so far. So this entire page here has to do with purchasing. So that's what we are going for. And the first 4 problems, if you read the last sentence of the first 4 problems, find the cost of each on number 7. Number 8, find the cost of each. Number 9, find the cost of each. Number 10, find the cost of each. So you're trying to find out how much each item costs by itself on these first 4 problems. Now in the last one, number 11, it says find how many of each type were sold. So the last one there is going to tell you how much things cost, and you have to find out how many of each kind were sold. But the first 4, you're trying to figure out how much each item costs. So let's start up here with number 7. Now it gives us total amounts, but it doesn't give us individual amounts. So it says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. And then 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. Yeah, Kai. What was that? The paper appears to be what? Oh, the actual paper. Oh, the gray at the bottom. We'll talk about it when we get there. We might not. All right. So this says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. So first thing we need to do is define our variables. There are 2 items here. What are those 2 items? What's our first item? What's the first thing that's mentioned? What item is mentioned first in this problem? Boxes of envelopes. Yeah. So we're going to say we want to know the cost of each. So that's what we're looking for. So cost, so price per box of envelopes. That's what X is going to be. So our answers are going to be in dollars and cents because we're trying to figure out how much they cost. And then the Y is going to be the other thing that's being mentioned here, which are boxes of notebook paper. So price per box of, I'm just going to say paper. We don't need to necessarily say notebook paper. We can just say paper. So those are going to be what we are figuring out. So our first equation, we're going to write 2 equations next. 3 of the boxes of envelopes, that would be envelopes times 3, right? Envelope boxes times 3. So that'd be 3x. And we're adding these together, plus, and means plus, 4 boxes of notebook paper. So 4 times the other kind. So 4y is equals $13.25, 13.25. I'm not going to use the dollar symbol right now. We'll add that back in at the end of the problem, but we definitely will add it back in. And then the other one says 2 boxes of envelopes, so 2x, and 6 boxes of notebook paper, so plus 6y, is equal to $17, so 17. And I'm going to write 17.00 just so we've got those decimals all nice and lined up. So that is how this one sets up. Those are our 2 equations. And these are all lined up. X's on X's, Y's on Y's, numbers on numbers. This is all set up for elimination. So we have to figure out what to do here. Now, none of the numbers yet match up. So we do have to do some multiplication to make this work. Which of the 2 equations should we multiply? First one or second one? What do we think? That's almost a trick question. Can we get away with only multiplying one of these equations on this one? No. Okay. So then we have to decide, do we want to eliminate x's or do we want to eliminate y's? So somebody tell me, x's or y's? X. All right. So if we eliminate x, we need to find a number that 3 and 2 multiply into. What number do they both multiply into? 6. All right. So the top equation, 3 times 2 is equal to 6. So we'll multiply the top equation by 2. The bottom equation, 2 times 3 is equal to 6, but we were going with opposite values when we were doing this, so we could add the equations together. So we'll multiply not by 3, but by -3 across the bottom. So multiply 2 across the top, 3 across the bottom, and that'll give us 2 adjusted equations. 2 times 3x, that's 6x. 2 times 4y is 8y. And 2 times 1325 would be 1650, or 2650, sorry, 2650. So we got 6x plus 8y equals 2650. And then across the bottom, we're multiplying by -3. -3 times 2x is -6x. -3 times 6y would be -18y. And then -3 times 17 would be -51. All right, now we are in a position to eliminate. We have opposite values with our x variables, so we're going to be able to add these two equations together. And when we add them together, the positive 6x and the negative 6x will cancel. The 18y plus -18y would be -10y. And then I'm going to use my calculator on this one. 2650 plus -51 is -2450. And then we'll divide both sides by -10. And y equals positive, which is important here because we're spending money. These numbers should end up being positive. 2.45. So y equals 2.45. Great. Which means that each box of notebook paper costs $2.45. Now we need to figure out the cost for a box of envelopes. And so we're gonna have to plug in y back into one of our original equations and then solve for x. Let's just go ahead and plug that back into the first equation. So that'll be 3x plus 4 times y, which is 245, equals 1325. So 3x plus 4 times 245 equals 1325. If we multiply 4 by 2.45, that's 9.8. So 3x plus 9.8 equals 13.25. We'll subtract the 9.8 from both sides. And that's 3.45. So 3x equals 3.45. The last step is to divide both sides by 3 to get x by itself. And it's 1.15 for x. So what we have here, boxes of envelopes, $1.15 each. Boxes of notebook paper, $2.45 each. So $1.15 for envelopes and $2.45 for paper. For the types of for each box that. So that would be the cost per for each of those. And I'll tell you what, the next three problems are so similar that we're gonna go back to our assignment now. I'm not gonna say that we're gonna keep working on those because the next three problems are just like the one we just did. So what I would prefer is to find a problem just like the one that we did here. So does anybody see a problem on the assignment where you're trying to find the cost of each type of something? Read through your assignment real quick. Tell me if you can find a problem that's telling you to find the cost of each type of something. Morning. Thank you. Which one? 6. Let's see, where did we go? There it is. Problem number 6. How much did each DVD and book cost? Yeah, find the cost of each. So problem number 6 from your assignment. Here we go. Number 6, David bought 3 DVDs and 4 books for $40 at a yard sale. Anna bought 1 DVD and 6 books for $18. How much did each DVD and each book cost? So again, this is just like the one that we just did. So the first thing that's on there are DVDs. So we're going to say X. It's going to be price per DVD. And then Y is going to be the cost or price per book. All right. The next thing we need to do is write 2 equations. So somebody tell me, what will our first equation be? Got to write 2 equations next. What's our first equation? Think about it for a second. Somebody let me know. What is our first equation going to say? Yeah, so how's that going to look for our equation? Yeah. So 3X, 3 DVDs. Oh, this should say and 4 books. Sorry. It says 4 books. 3 DVDs and 4 books. All right, typo. So the and would mean what in our equation? Plus, good. And then 4 books, what would that look like? What is it? So 3X plus 4 books. So plus 4 what? 4Y, yep. The cost was $40, so is 40, so equals 40. So 3 DVDs and 4 books cost $40. Okay. How about the next equation? What's that one going to say? Good. 1x plus 6y. How much did that cost? $18. Nice. All right. Now we've got our system of equations set up. I'm going to leave it at that. I want you to be able to solve that later. So, so far we've seen a couple different types. We've seen relating 2 numbers together, and we've seen figuring out the cost of 2 items. The third and final type of problem that we're going to see today is number 11 from your notes. And this time, it gives us the cost of the types of items, and it wants you to figure out how many of each were sold. So Before we even start this, I'm going to read through it and I'm going to ask you about what kinds of answers would actually be reasonable here. So a garden supply store sells two types of lawnmowers. The smaller mower costs $249.99. The larger mower costs $329.99. If 30 total mowers were sold and the total sales for a given year was $8,379 and I think that says 70 cents. Yes, $8,379.70. Find out how many of each type were sold. So there are two types of lawnmowers. So the smaller lawnmower, that's our first one. So X will be number of, because we're trying to find out how many of each type were sold. So this is no longer price because we know how much they cost. Number of small mowers. And then there's a larger one as well. So that would be the Y variable. So Y is going to be number of large mowers. All right. Now, there's definitely more information on this one, and the way that the information is provided is a little bit different as well. So it tells us, first of all, that the smaller mower costs $249.99 and the larger mower costs $329.99. But that right there is not enough information to actually write an equation. It's just giving us information on how much they each cost, because it's not relating it to anything. Do you see that? How it's just telling us the information, it doesn't relate it to anything. The relation comes later. And it says 30 mowers were sold. Now that right there, if 30 total mowers were sold, that right there will be our first equation. The fact that 30 lawnmowers were sold. Does anybody know what that would look like if we were to write an equation saying that 30 lawnmowers were sold? We're talking about number of, right? So that's the number of small lawnmowers and the number of large lawnmowers, and there were 30 of them sold. What would that look like as an equation? Number of small mowers is what? What do we say that was for our variable? X, right? Small mowers are X, large mowers are Y. So if there were 30 lawnmowers sold, we don't know how many of each type were sold. We just know that a certain amount of small mowers were sold and a certain amount of large numbers were sold and large mowers were sold. And the total amount sold was 30. So that would be X, number of small mowers, plus Y, number of large mowers, equals 30. 30 mowers were sold. So that is our first equation here. So it says if 30 total mowers were sold, that's our first equation. And here we go. Total sales for a given year was $8,379.70. Find out how many of each type were sold. Now, we know how much each type costs. We do not know how many of each were sold. So the second equation is going to be the cost of each times the number of each, which we don't know, adds up to a total of $8,379.70. So here's how this one's going to look. Small mowers are $249.99 each. So we're going to say $249.99 X times the number of small mowers plus $329.99 Y times the number of large mowers equals the total amount sold, which was $8,379.70. So those are our two equations. This one's pretty different than the last type of problem we looked at. So what we need to figure out now is which method should we use? Or not should. Which method do we want to use? How about that? Well, do we want to use substitution or elimination here? And honestly, it doesn't matter which one we use. We just need to pick one and kind of go with it. So first person to say substitution or elimination, that's what we're going to use. Let's pick one. Nobody wants to make a decision, huh? Either way, there's a little bit of work that has to be done in order to use either one. About the same amount each way. So throw one out there. Elimination. All right. So if we're going to use elimination, that means we need to get the opposite value with x or the opposite value with y. And right now, our first equation is 1x and 1y. So the multiplication here, it'll be easy to get the same number, opposite number in front of either x or y. Now, using a calculator might be handy in terms of the multiplication for 30. So do we want to eliminate x or y? Again, it doesn't matter. All right, let's eliminate y. So we're going with elimination. We're going to eliminate y, which means we need to get the opposite of 329.99 in front of y, which means we'll multiply the entire first equation by negative 329.99. All right. So here we go. We're just going to rewrite the first equation. We'll rewrite the second equation. So if we multiply x by negative 329.99, that's just going to be negative 329.99x. So here we go, negative 329.99x. And then the same thing for y, minus 329.99y equals 30 times, so I'll do that real quick, 30 times negative 329.99. And that's negative 9,899.70. All right. Now the second equation stays exactly the same. So that's going to be 249.99. A lot of decimals on this one because we're talking about money. Plus 329.99. Y equals 8379.70. All right. Cool. So we're all set up for elimination. Now, before we move on, I do want to ask a question here about reasonableness for our answers. What types of numbers should we get for x and y? Like in terms of selling lawnmowers, what types of numbers make sense here? Could you have negative numbers for answers on these? Is that possible? Can you sell negative lawnmowers? No. So negative numbers, not going to make any sense. Can you sell anything but a whole number of lawnmowers? No, you can't. You can't sell 2.5 lawnmowers. That doesn't work. So what we're looking at here is we should end up with positive whole numbers for our answers for both of these. Those are the only numbers that actually make sense when you're selling something like lawnmowers. You sell 1 lawnmower or 2 or 3 or 50, whatever it is. So let's go ahead and keep working through here. Now our negative 329 and positive 329y's, those will cancel out. And then we're going to do negative 329.99 plus, we're adding these together because we've got opposites, so add them together, 249.99. And that's negative 80. That's a whole number. Great. So negative 80x. Off to a good start. Hopefully whatever this number is divisible by 80. I'm guessing it probably will be. So we'll take our negative 9,899.70 and then we'll add to that 8,379.70. And that gives us negative 1,520. Now, both of those numbers are negative, which is a good thing because when we divide the negatives, we'll end up with a positive. And hopefully, Negative 1,520 divided by negative 80 ends up being a nice whole number. Let's find out. Divide by negative 80. Yeah, there it is. It's 19. So x equals 19. So that means they sold 19 small mowers. Great. Now let's just think about this for a second. If they sold 30 lawnmowers total and 19 of them were small lawnmowers, how many of them were large? They sold 30 total, 19 were small. How many would have to be large? What's that? Well, let's find out. So x is 19, and we can just plug back into our very first equation. So block that off for a second. So x is 19 plus y equals 30. So if we subtract 19 from both sides, 30 minus 19 means that y equals 11. So 19 small and 11 large. That is our answer for problem number 11. So in terms of notes for today, that's it. Before we keep going though,